In this video for Positive Maths, we're going to learn about complex numbers. So when it comes to addition and subtraction of complex numbers, we add and subtract the real and the imaginary parts separately. So the rules are very similar to that we use for algebra as well. So let's go through an example to see how it works. We have the first example, 6 plus 2i plus 4 minus 4i. So we add the real parts, so 6 plus 4, and we can add the imaginary parts. So we have 2i minus 4i. So 6 plus 4 gives us 10. 2i minus 4i is going to give us minus 2i. Let's look at the second example. We have 3 plus 2i minus 4 plus 5i when we get rid of our brackets. So 3 minus 4 is going to give us minus 1. 2i plus 5i is going to give us 7i. And our third example, we have 7i minus 3 plus 2i minus I plus 12. So for the real parts, we're going to get 9. And then we have 7i plus 2i minus I. This is going to give us plus 8i. So again, when adding or subtracting complex numbers, we add and subtract the real and the imaginary parts separately. So moving on to multiplication. When multiplying complex numbers, we remember the rules that we learned for algebra as well. We must, however, remember that I squared is equal to minus 1. And it's important that whenever we have I squared in an equation, we change it to minus 1. We will never leave it as I squared. Okay, so let's go through our examples. The first one, we have 6 plus 2i multiplied by 4 minus 4i. So this is going to give us 6 multiplied by 4 minus 4i plus 2i multiplied by 4 minus 4i. So we multiply our 6 into our first bracket and we get 24 minus 24i. Then we're going to multiply 2i into our bracket. We're going to get plus 8i minus 8i squared. Okay, so now we need to simplify. So 24 will stay as it is for the moment. Minus 24 plus 18 is going to give us minus 16i. And our I squared is going to change to minus 1. So now we're going to have minus 8 multiplied by minus 1. So we have 24 minus 16i plus 8. So this is going to give us 32 minus 16i. Let's look at part 2. We have 3 minus 2i multiplied by 4 minus 5i. So again, we're going to multiply out our brackets. So we'll get 3 by 4 minus 5i minus 2i by 3 minus 4i. So we get 12 minus 15i minus 8i plus 10i squared. So we'll get 12 minus 23i plus 10 multiplied by minus 1. So we get 12 minus 23i minus 10. So we get 2 minus 23i. And our last one, part 3. We have minus 3 multiplied by 2i minus I plus 12. Okay, so here we're going to simplify what's in the brackets first. So we'll have minus 3 multiplied by I plus 12. So we'll get minus 3i minus 36. So again, when multiplying our complex numbers, we remember the rules that we learned for algebra. We must remember that I squared is equal to minus 1. So the rules here that we learned for algebra is that really, if we have minus 3 multiplied by 2 plus x, we know that we multiply the number by every term inside. So that will be minus 6 minus 3x. So similarly, if we have minus 3 by 2 plus I, that's going to be minus 6 minus 3i. So let's look at another problem-solving activity. involving addition, subtraction and multiplication. So we're told that Z1 is equal to 6 plus I, Z2 is equal to 5 plus 3I. The first part asks us to find Z1 plus Z2. So Z1 is 6 plus I, plus Z2 is going to be plus 5 plus 3I. So here there's no multiplication, we just add the real parts and the imaginary parts. So 6 plus 5 gives us 11, I plus 3I gives us 4I. Part 2, 3Z1, so that's 3 multiplied by 6 plus I, plus 5Z2, so that's 5 by 5 plus 3I. So the first thing we need to do is multiply out our brackets. So we'll get 18 plus 3I plus 25 plus 15I. So 18 plus 25 will give us 43, and 3I plus 15I gives us 18I. And the last part, we have minus Z1, so that's minus by 6 plus I, minus 3Z2, so that's 5 plus 3I. So we have minus 6 minus I, minus 15 minus 9I. So we're going to get minus 21 minus 10I. Okay, another problem solving activity. We have to find Z1 when Z1 plus 5 plus 2I is equal to 6 minus 4I. What we're remembering is that Z1 is going to be in the form of A plus BI. So we are looking for the real part and the imaginary part of this number. So we're going to treat it like an equation and solve for Z1. So that means we're going to have Z1 is equal to 6 minus 4I minus 5 minus 2I. So I subtract 5 from both sides to get rid of the 5 on the left, and I subtract minus 2I from both sides. So I also get rid of that 2I on the left. Okay, so let's simplify what we have on the right. 6 minus 5 gives us 1. 4I minus 2I gives us minus 6I. So if we know that Z1 is going to be in the form of A plus BI, so a real part plus an imaginary part, and that's equal to 1 minus 6I, then that's what our Z1 is going to be equal to. And just to note, the real part of Z we have found is 1, and the imaginary part of Z is minus 6. For more information, visit www.PositiveMaths.ie, email us at info@PositiveMaths.ie, and find us on Facebook and Twitter. Thanks for watching.